So this question asks us to find out whether we can finish all courses. And because the courses may have prerequisites, that means we need to finish these courses in a certain order. For example, in this case, A does not have any prerequisite, and B has one prerequisite, which is A. C has two prerequisites, which is B and B. Naturally, we know that we need to finish A first. After doing so, B's prerequisite is satisfied, so we can finish B. But we can't finish C at this point because the other prerequisite of C, which is B, is not finished. But after doing so, we can finish C. So this is order we want to finish these three courses. However, in this case, we won't be able to finish all the courses because A and B depends on each other. So now we just need to write a program to solve this problem. This method is called topological sort. If we want to look at this as a graph, we will discover that the number of prerequisites a vertex has is the number of edges that point into that vertex. And we call that the integrity of the vertex. So the integrity of A is 0, B is 1, and C is 2. And like what we did previously, what our program needs to do first is to find all the vertices that has an integrity of 0. These are the vertices that can be handled without worrying anything else. So in our case, we have one node A that satisfies this condition. And since A is handled, we can find every edges starting from A to some other vertices, subtract those vertices in degree by 1, because one of their prerequisites is handled. So we find B and C, and subtract their integrate by 1, making their integrate to 0 and 1. Then we find out that B's integrate is also 0 now, so we can do the same process to B. And that would make C's integrate become 0, so C can be handled. And the node is pretty straightforward. Just use a stack to store all the vertices that can be handled at the moment and add more during the process. Check the number of vertices we handled and compare it to the number of courses. If they are equal, then the answer is yes, otherwise the answer is no. So looking back to this, we can find that if the answer is yes, then there is not a loop in the graph. So topological sort is also a way to find whether there exists a loop in a graph.